Hi! Here are two radioactive pieces of metal. I paid a lot for them since they should be rare, hard to find element samples. High purity uranium and thorium. But are they really? One of them I bought on eBay, so have I been fooled? A Geiger counter can't tell me the truth. It can only show me if something is radioactive or not. It has no idea of what radioactive element is near it. However, a gamma-ray spectrometer like this one can identify a radioactive element if the sample is emitting gamma rays. But uranium and thorium are not known as gamma-ray emitters. They mostly emit alpha particles. I wonder what a gamma spectrometer will pick up near these two samples then. Are there any signs of them being what they claim to be? Let's find out. Always respect radioactivity and take the necessary precautions. For this rather difficult, perhaps impossible task of confirming purified uranium-238 and thorium-232 by gamma spectroscopy, I will use the latest spectrometer from RadiaCode. This new model, the 110, is a bit larger than the others since it contains a bigger scintillation crystal. This makes it better and faster at detecting low radiation levels from small samples, highly needed for my tiny milligram samples. Here we can see how the 110 picks up more than twice as much of the weak background radiation at my place. 7 counts per second is really good for this small a device. For perspective, this similarly priced Geiger counter is only detecting 0.2 to 0.3 counts per second, making the 110 around 30 times more sensitive, and it has the spectrometer function unlike any Geiger counter. Will it be able to detect this as uranium or something else? I bought this sample on eBay back in 2010. It is supposed to be depleted uranium, containing mostly uranium-238 with a half-life of a whopping 4.5 billion years. Since it decays so slowly over billions of years, it is barely radioactive measured in real time, and I haven't found a way of fast-forwarding time that much yet. It doesn't help that my sample is only around half a gram, but let's give the RC110 a chance of detecting nearly nothing. To get the sample as close as possible to the detector, I will place the RadiaCode upside down and place the sample on top of its back, right over the center of the detector, marked with the plus sign. Oh, it surely is detecting something. I will turn off the alarms and give the spectrometer some hours to measure the spectrum. Note how I am a lazy amateur, not a trained spectroscopist following good practice. I just turned the spectrometer on and placed a sample on it. That's it. After 4 hours, I lost my patience and started looking for signs of uranium. Oh, hold on. I see some weak photo peaks at interesting places in the spectrum. Look at that. All of the 5 major peaks in this captured spectrum could be linked to uranium. The calibration is not perfect, because I didn't calibrate, but especially this pair around 766 and 1001 kiloelectron volts is a well-known fingerprint. They come from protactinium-234M, an early gamma emitter, second order, in the U-238 decay chain. And the 2 lower peaks could be from thorium-234, the first gamma emitter U-238 turns into. There is likely also some breaking radiation from beta radiation hitting the glass vial that messes up the lower peaks. I don't see clear signs of lead-214 or bismuth-214, which are common peaks in uranium-related spectrums. But the lack of these makes sense. This is not natural uranium in equilibrium with all its daughter isotopes. It is depleted uranium. Uranium metal purified recently, where all daughters like lead and bismuth were removed. It will take over 1 million years before this sample has decayed into equilibrium again. I don't want to wait that long to call it, but I feel pretty sure. This spectrum proves this is a sample of uranium-238 metal. Great! Next up is the thorium sample. This is unfortunately a much smaller sample. It was sold without a specified weight, but I guesstimate it to be around 35 milligrams. To make things even worse, Thorium-232 is also much less active than Uranium-238. Thorium-232 has a half-life of 14 billion years. Even at a universal timescale, 14 billion years is a very long time. I mean, it is as long as time itself has existed. I don't like the low odds of success for this one. Well, it is picking up something. I gave the spectrometer 50% more, 6 hours, to collect data from this tiny sample. But the result is not exactly what I was hoping for. I don't see any clear fingerprints from any radioisotope. I think it is mostly break-in radiation from beta particles or X-rays. And of course background radiation, which I didn't shield against. At least there are not clear signs of this thorium sample being something else. I just don't have the solid positive proof I was hoping for. I assume it is just too much to ask for a gamma spectrum from a recently purified 35 mg thorium sample. Maybe it will help if the thorium sample is quite a lot larger. We will find out after this short message. A huge thank you to all my patrons. Thank you so much for helping out. It's really appreciated and important for a niche channel with monthly quality uploads like mine. For just $1 a month, you can help me out too and get full access to all my posts on patreon.com. Link to my Patreon page in the description. Thank you. Alright, time to test some other samples that are often said to contain thorium. But do they really? This is a mantle lamp. Back in the good old days, the mantle was spiced up with thorium nitrate to make it glow more brightly white once lit up. It sure is radioactive from something in it. Another example is thoriated tungsten welding rods. Well, as my patrons already know, this particular package is fake. I got scammed by an eBay seller. These red-tipped electrodes should contain 2% thorium oxide, but they are not radioactive. I have made up for this by buying the hottest welding rods available. Orange-tip ones with 4% thorium oxide. These are definitely radioactive. But is it from thorium? What gamma spectrum, if any, do they emit? After just 5 minutes, a spectrum I haven't detected before was forming. I gave it an hour to sharpen up. Let me remove these sources before taking a closer look at the spectrum on the laptop. I do aim to live by the Alara principle. What do we have here? This is fantastic. There are clear markers for actinium-228, thallium-208 and lead-212, all related to thorium-232. Even the 2614 kV peak from thallium-208 is visible. That's usually considered hard to detect. Some say a big 2x2-inch detector is necessary to detect such a high-energy photon. Nice! It was surprisingly easy to verify that thorium is present in this stack. Let me know in the comments if you are interested in an attempt at catching a spectrum from uranium in natural equilibrium. I have some hot pitch blende samples that might stress test the RadiaCodes. Hope you enjoyed this video enough to click like and perhaps subscribe for more like it. In any case, thanks for watching. Bye for now.